Hello everyone. In this part of the video, we will be going to talk about exploratory data analysis on the text data. So first of all, let us understand what do you mean by EDA. EDA basically means we use various types of graphical and statistical method in order to bring insights from the data. So basically what you are doing, you are uncovering the hidden insights which are present in the data. So first of all, what I'm going to do, I'm going to check the length of the tweets. So for that purpose, I'm going to create a column called as tweets length column. And here I'm going to calculate the length of each tweet. Once this is done, after that what I'm going to do, I'm just going to make it a histogram and plot the distribution of tweets length. So here, first of all, you can see I am setting my figure size. Then I am just doing hist plot for making the histogram. And after that, I am giving the title and I am just showing the plot. So let me just run this out. So here we can see this is my histogram. If you can see, most of the tweet length is under the 50 character. Very few tweets which are more than 300 character. So this is all about the distribution of the length of tweet. The next step is to visualize the word cloud. So what is a word cloud? A word cloud is a visual representation of your textual data. So let me first of all, what I am to do, I will join all the words present in the clean tweet. Once this thing is done, what I am going to do next, I am just going to make the word cloud. So here we can see I am calling the word cloud function, and here I am passing the parameter like width is 800, height is 800, background color is white, and remove if there is any stop words present, just remove it out. We have already take care of that, so don't worry about it. And here the minimum font size of a particular text will be 10, and it is going to generate for all the text. Once it is done, what I am going to do, I am just going to plot it out and display you the word cloud. So let me just run it out. So here we can see this is my word cloud. You can see what are the most frequent words in the document. We have Elon Musk, we have Nikola Tesla, we have Twitter, we have Tesla. So these are the most frequent words present in my document. Similarly, smaller words will be like soon, said, buy, Tesla. These are the words which I have in lower frequencies. That's why it is font size is lower. So this is all about the word cloud. Now we have seen how to create histogram for checking the distribution of length of tweet and how to create word cloud. The next step that I am going to do, I am just going to find out what are the most popular hashtags which are commonly used in the tweet. So here we can see I am going to use lambda expression. So first of all, I am applying some function, taking the tweet column and applying the lambda expression. So what lambda expression is doing, if any tweet, like if anything which start with hash will be considered as hashtags, and it will be counted it out. So if I just print it out, you can see these are the hashtags present in my dataset. Once this thing is done, what I am going to do next, I am just going to see the frequency, like what is the frequency of each hashtags. So here we can see the most frequent hashtags like Tesla is 721 times, Elon Musk is 183 times, renewable is 32 times, and so on. So these are the frequency of the hashtags used in the post. Next, I am just going to convert this frequency distribution into a data frame. So after that, what I can do, I can just plot out the. So here we can see this is my data frame. Once it is done, next what I am going to do, I am just going to make a bar plot for finding the most frequent hashtags. So here I am just going to select the top 10 hashtags, and after that I am just plotting it out with the help of matplotlib library. So here we can see these are the most popular hashtags we have available. Tesla is the most common one, second one is the Elon Musk, third is the Twitter, fourth is the EV, and so on. So these are the top 10 most popular hashtags we have. Next, I am going to perform n-gram analysis. So first of all, I am going to import all the required libraries. So from NLTK, I am going to import ngram And the from collection, I am going to use counter library. So counter will basically count the number of items. Then I am defining my bigram. So here we can see n-gram, converting the text into lowercase, splitting it out. And after that, I want bigram. So I have written here 2 here. Then I am going to count the frequency of the bigram. After that, I am going to select the top 20 and convert it into a data frame. Once it is done, after that what I am going to do, I am just going to plot out the top 20 bigram. So here bigram.df.plot x is equals to bigram and y equal to frequency. The plot will be of horizontal mode, like bar plot in horizontal mode, and this is my figure size. After that I am giving the table. After that I am giving the title, then label, then x label, then y label, and displaying you the graph. So this is basically my top 20 most frequent bigrams. Similarly, if you want to plot trigrams, what you can do? You can just write here 3. Take the top 20 and after that you have to plot it out. So this is my top 20 trigrams. So you can see Tesla Model 3, CEO Elon Musk, Tesla CEO Elon. The question is, why do we use n-gram? To basically find out what is the context of the topic. So here we can see in this particular post we are talking about the Tesla Model 3 version. Here we are going to talk about the Tesla Mac version. So these are the things we have. Next, I am going to perform sentiment analysis. You all know what sentiment analysis is, classifying the tweet into positive, negative or neutral. So first of all, you can see I am going to import my important libraries like NLTK. Then I am going to import sentiment intensity analyzer. Then I am going to download the Vader lexicon. So these are the dependencies needed in order to perform the sentiment analysis. Now I will initialize my Vader. So Vader is a sentiment analysis tool that is used for performing the sentiment analysis. So this is how you initialize Vader. After that, I am going to calculate the score of the sentiment on the clean tweet data. So here we can see I am applied here the lambda function, which is lambda of x, SIA dot polarity score x. So you can see it is applying sentiment analysis. Once it is done, I am just going to give it the label. Like if score is greater than 0.05, it will be positive. Else, if it is less than that, it will be negative. Otherwise, it will be neutral. Now let me just plot it out, my sentiment score with the help of histogram. You can see most of the tweets we have is neutral. Second of them are positive and others are negative. Next, what I am going to do, I am just going to plot it out, a bar plot. So here we can see most of the tweets are neutral. Second one is the positive one and the third is the negative one. So this is all about the sentiment analysis. Now I am going to talk about how to find out the top 10 rare words in your document. So first of all, what I am going to do, I am just going to combine all the clean tweets into one single string, which is all words. After that, I am going to apply the counter function, which will calculate the frequency of each words. So let me run this out. Next, I am just going to take the top 10 rarest word, like whose frequency let us say is 1. So we are going to take the top 10 rare words in the document. So here word frequency dot most common function and colon slash -1 basically means reverse the string, like do it from reverse order and taking the top 10. Once you get it, after that I am just going to create the data frame for the rare words containing 2 columns, which is word and the frequency. Once this thing is done, I am just going to plot them out in a bar plot. So here we can see a bar plot is getting created having 2 columns, frequency as well as the word. Then palette I have set to magma. Why? Because it is a color palette. That's why I have written it magma here. Then I am going to give the title, give the X label, give the Y label and display it out. So here we can see these are the rare words present in my document, like powerhouse, remaja, cell pass. So these are the most rare word present in my tweet. Once this is completed, next I am going to talk about count vectorizer. So what is count vectorizer? If you remember, we convert the text into numerical representation. So first of all, what I am going to do, I am just going to import the library. So from sklearn.featureInstruction.txt, I am going to import count vectorizer. Now I am going to initialize the count vectorizer. And here I am going to pass several parameters. Let us understand each one by one. Max underscore df is 0.95. It means remove the most frequent word which is occurring more than 95% of the document. And min df equal to 2 means remove the words whose frequency is 2, like whose word frequency is 2. After that, I am going to define my stop word as English because we are working on English data. I am going to fit and transform it on the clean tweet. So here count vectorizer dot fit underscore transform on the column name. Once this thing is done, let me print my feature name here. So here we can see I am going to print out my feature name. So count underscore vectorizer and the function is get feature names out. So these are the feature names of that word. You can see. Now here we can see we are taking the top 5 keyword by count for each tweet. So first of all, I am creating an empty list. Then I am iterating through over a data frame and I am just calculating the feature index as well as the count score. After that, I am appending both the things in the top keyword count. So let me run this out. And here we can see, let me just print this thing. So you can see for clean tweet, this is the clean tweet and this is the keyword count. So top 5 keyword count will be there and along with their frequencies will be given. So this is all about the count vectorizer. Here you have to remember that these are the most important parameters. It may ask you in interview also. Like sometimes people can ask like, can you tell me what is max df? So here you have to tell it. Like it is the most common words which is present in the 95% of the document. So you have to remove the most common words which are present in the 95% of the document. Min df equal to 2 means remove the rare words which frequency is less than 2. So this is all about count vectorizer. Similarly, we have TF IDF vectorizer, also known as term frequency and inverse document frequency. So first of all, I am going to import it out. Then I am just going to take the same parameter as above. Like max df will be 0.95, min df will be 2. Then I am going to fit and transform it on the clean twist data. After that, I am just going to print the feature names. Once it is done, I am just going to print the top keyword for each tweet. Now let me display you the data. So these are the top keywords for each tweet based on the TF IDF vectorizer. Next we have topic modeling. Topic modeling basically means you assign a topic to a tweet. So this thing is called as topic modeling. So basically you give some topic. Let us say we have bunch of text given here. We are categorizing, like clustering them in a topic. Let us say one article is belong to the sports news. One article is belongs to the economics news. So that is the topic modeling. You assign the topic to that tweet. So first of all, I'm just going to import count vectorizer. And for topic modeling, the algorithm that I'm going to use is called as LDA. LDA stands for latent Dirichlet allocation. Then I'm just going to initialize my count vectorizer and then I'm going to fit and transform for the clean tweet. After that, I'm going to initialize my latent Dirichlet allocation. Number of component is 5 means there will be 5 topics total will be there. And apply it on count vectorizer data. You can see the topic is generating. Next, I'm just going to create a function called as display topics and it will display me the topic's name and what are the contents present in that topic. So here I will just call this function and print the top 10 words for each topic. So there will be 5 topic total. Topic 1 will be there. These are the top 10 words. Topic 2 will be there. These are the top 10 words and so on. So this is all about the topic modeling. You assign a topic to the tweets. Now I am going to implement word to vec. Word to vec basically is an embedding model which will convert your word into the embedding. So first of all, I am just going to install the Gensim library because it is needed for implementing the word to vec. So let me install it out. Once it is installed, what you have to do, you just have to import the word to vec from the Gensim library. Then I am going to import my word underscore tokenize function. So here we can see this is the common issue you can face. So what you have to do whenever this type of issue you will face, like numpy.dtype size change, you just have to simply go to runtime, restart the session and run all. So this is the thing that you have to do in order to fix this kinds of issue. Now you can see the issue is fixed. Next what I am going to do, I am just going to take my clean tweet data and tokenize it out and convert them into a list. After that, I am just creating the word to vec model. So here word to vec will be there, and first of all I am passing my tokenized tweet. The vector size will be length of 100 and the window will be 5. So window is 5 basically means, let us say there is a target word. So how many words before that and how many words after that. So target word, before that there will be 5 word and after that there will be 5 word. So this is basically my window size. Minimum count is 2. So minimum count is 2 basically mean that your count is basically 2, like removes the rare word which are occurring frequency less than 2. So here worker is 4, like number of CPU cores. Then SG equal to 1. SG is equal to 1 means we are using the skip gram model that we have already talked about in the previous video. What is skip gram and what is SIBO W. And XG is equal to 0 means we are using the SIBO model. So let me run this out. After that, you can see I am just printing the vector representation of the word happy. So word to vec model dot wv then happy. So here we can see this is the vector length for 100 for a particular word happy. Similarly, this is I am printing it for second word which is love. So these are the most similar word corresponding to love, like pretty love, must love, cool love. So these are the things which are the most similar to that word love. Then here I am just going to apply SIBO model. So SG equal to 0 will be there, rest everything will be same. And once this thing is done, I am just going to print the vector representation for word happy. And let us see what are the most common words, like what are the most related word related to love. So this is basically all about the word embedding, basically word to vec model. Here we have completed our exploratory data analysis.